All right, good morning. Algebra 2 classes, doing a little video here on the Desmos calculator. I just want to give you a little bit of a demonstration, and I think this is going to sort of help you guys visualize what we looked at with 1C, and this will kind of help you get into the 1C part 2 notes as well. So let me hide this thing right here. So I'm going to sort of come off to the bottom here. So let's say we have just a straight function f of x. Where's my pen? Oh, that's why I don't have a touch screen. Sorry. So say we just have a simple quadratic function, f of x is equal to x squared. Okay, f of x is equal to x squared. So if we come into a Desmos calculator right here, what we can do, we'll just type in y, or you can even type in f of x if you want to. And type in x squared. All right, and we get our function right there. Okay, quadratic function. You could do any function you want, but I think I wanted to do x squared here because I think it's easy to sort of visualize, and we kind of looked at it a little bit in some of my earlier classes on Thursday. So let's say hypothetically we want to do something like, vertically translate up by 2. Okay, so if we want to go up by 2, okay, what we're going to do is we're going to take f of x. And we're going to add 2, okay? Well, what is f of x equal to? F of x is equal to x squared. So what we're going to have is we're going to write it as x squared plus 2 if we want to go up by 2. Okay, so here we'll go y equals x squared, arrow key plus 2. All right, and there we have it done, plus 2. Now let's say we want to move it to the right by 4 or something like that. Okay, so if we want to move it to the right by 4, all right, what we're going to have is now we're going to have f of x minus 4. Shouldn't be plus, should be minus. Okay, so f is x squared. So what we're going to do is instead of x squared, we're going to have x minus 4 squared. So we type it in here, y equals parentheses, x minus 4, close parentheses, squared. And so it moves to the right by 4. Okay, horizontal translation. All right, let's talk about stretching it real quick. So let's say we want to stretch by a factor of 3. I'm going to erase all this stuff on the bottom here so I have a little bit of room. So if I want to stretch it by a factor of 3, a vertical stretch by a factor of 3, so we want to go vertical stretch by 3. Okay, we're going to do 3 f of x. And remember, coming back up here, f of x is equal to x squared. So now we're going to go y equals 3x squared. And there we get that black line here where it basically stretches by a factor of 3, okay? And in this original function, we can kind of look at it here. So see how we have the 0.11 right there in our original? Okay, so we have 1, 1 right there. Well, now look what we have on this black one. We have 1, 3. And we can even clear these other 2 out if we need to, right? So we vertically stretch by a factor of 3. So now at each x value, the y value is 3 times as high. All right, horizontally stretching. Okay, if we're going to horizontally stretch, now we're going to multiply by a number that's less than k. So let's say we have a horizontal stretch. All right, and for a horizontal stretch, our k value needs to be less than 1. Let's say we want to do a horizontal stretch by half. Okay, horizontal stretch by half. So now we're going to go f of 0.5x, or f of 1/2 x. Okay, so y is going to be equal to parentheses 0.5x squared. All right, and now we see we horizontally stretched it. Really, what is a horizontal stretch by a factor of 2. So we're basically multiplying the k by 1/2. Okay, kind of the opposite, kind of the same with the horizontal translation. So now, on our original function, we have the 0.11 here. Now we horizontally stretch it. So now look what we have. We have right there. We have 2,1. So we horizontally stretch it by a factor really of 2. So we multiplied it by the reciprocal of 2, which is 1/2. All right, last two. Let's go. Let's clear these out here and look at our original. So let's say we want to do a vertical reflection. Okay, so if we have a vertical reflection, okay, remember that's going to be negative f of x. Okay, so negative f of x. Remember, side note, f of x is equal to x squared here. So y is going to be equal to negative x squared. And voila, now we have a vertical reflection, okay, over the x-axis. Here's our original x squared up here. There's our vertical reflection there. Last one here, I want to look at a horizontal reflection. So let's say we have a horizontal reflection. Right? So remember, horizontal reflection, now we're going to do f of negative x. Okay? F of negative x. So we have our x squared here, but instead of x, we're going to square negative x. So y is going to be equal to negative x squared. And look what happens. It's the same thing, okay? Because if we look at that, our original quadratic function right here, this f of x equals x squared here, that's in blue, right? If we were to horizontally reflect it across the y-axis, it ends up being the same function. It's the same thing. Okay, so hopefully this video kind of helps you guys visualize it a little bit. And I'm going to do one more example right here from our original. All right, so let's say hypothetically here, let's say we have a question that says, take our original function, x squared, and let's say it tells us that we want to go up by 3, to the left by 4, and let's say we want to vertically compress by 1/3, and let's say we want to reflect across the x-axis. Okay, so x-axis, so vertical reflection. Okay, so we have f of x equals x squared. So let's think about how we have to manipulate this thing here. Okay, so f of x equals x squared. So if we're going to go up by 3, so going up by 3, we know we're going to have to take f of x plus 3. Okay, and we want to go to the left by 4. So now instead of x, we're going to go x plus 4. So now going to the left by 4. In addition to this, now we're going to have f of x plus 4 parentheses plus 3. Next, when we have our vertical compression by a factor of 1/3, okay, now we're going to multiply this whole first part by 1/3. Okay, so the vertical compression of 1/3 is going to tell us now we're going to have 1/3 f x plus 4 plus 3. Lastly, if we're going to reflect it across the x-axis, that's a vertical reflection. All right, so now we're going to make our f negative. So now our vertical reflection is going to be negative 1/3. Whoops. F x plus 4 plus 3. So what that looks like in our function, now our function is f of x equals x squared. Okay, so to do this total thing here, so we're going to do our y equals negative 1/3 parentheses x plus 4 squared plus 3. And that's what that's going to look like when it's all said and done. Okay, so our original function was f of x equals x squared. We want to move it up by 3, to the left by 4. So up by 3, we add 3 to this thing. To the left by 4, which means instead of squaring x, we're going to square x plus 4. Okay, so instead of squaring the x, we're going to square x plus 4. The vertical compression, kind of like the slope, if you will. So we're going to vertically compress it by 1/3. Okay, so we're going to sort of press this blue thing down a little bit and make it a little bit wider, if you will, by 1/3. So there you have it right there. Okay, and then lastly, the reflection across the x-axis, that vertical reflection, now we just have to make it negative in front right there. Okay, so that's what this looks like in totality. So this should kind of help you visualize the 1C a little bit. You could really use any function right here, but I think the quadratic one's kind of easy to see how it kind of looks. So that's that. And if you want to use this to try the 1C part 2, go for it. And then if you want to fiddle around with Desmos a little bit and try to visualize all these things there and make up your own stuff, go for it. And we'll be around if you have questions, and then use this thing to get the 1C part 2 notes on. Thank you guys, and y'all take care.